Have you ever wondered how things move? Cars, trains, even your toys, many things move thanks to electricity. But how does electricity make things go? The answer lies in a special device called an electric motor. Electric motors are like tiny engines that transform electricity into motion. But first, let's talk about electricity. Electricity is like a stream of tiny particles flowing through wires, kind of like water flowing through a hose. This flow of electricity is called an electric current. To make something move, we need to control this electrical current. That's where circuits come in. An electric circuit is like a pathway for electricity to flow. It's a loop that starts at a power source, like a battery, travels through wires, and powers a device like a light bulb before returning to the battery. Think of it like a racetrack. The battery is the starting line, the wires are the track, and the light bulb is the finish line. Just like a race car needs a complete track to race, electricity needs a complete circuit to flow and power our devices. Now let's talk about magnets. Magnets are objects that create an invisible force around them called a magnetic field. This field allows magnets to attract certain metals like iron. You've probably played with magnets before. They're pretty cool. Every magnet has two poles, a north pole and a south pole. Here's the fun part. Opposite poles attract each other while like poles repel. So if you bring the north pole of one magnet close to the south pole of another, they'll stick together. But if you bring two north poles together, they'll push each other away. This invisible force of attraction and repulsion is what makes magnets so special and is key to understanding how electric motors work. What if we could create magnets whenever we wanted? That's where electromagnets come in. Electromagnets are like super cool magnets that we can turn on and off with electricity. Imagine being able to make something magnetic with the flick of a switch. To create an electromagnet, we need a coil of wire and a source of electricity. When electricity flows through the coil, it creates a magnetic field around it, just like a real magnet. The more coils we have, or the stronger the electric current, the stronger the electromagnet becomes. But here's the best part. We can reverse the direction of the electric current, and guess what? The north and south poles of our electromagnet switch too. This ability to control the magnetic field is crucial for making electric motors spin. Section 4. Electric motors spinning into action. Now we have all the ingredients to understand how electric motors work. Remember how magnets attract and repel each other? Well, an electric motor uses this force to create rotational motion. Imagine a loop of wire placed between the poles of a magnet. When electricity flows through the loop, it becomes an electromagnet. Now the loop's magnetic field interacts with the magnet's field, causing it to rotate. But here's the clever part. To keep the loop spinning, we need to switch the direction of the electric current flowing through it. This switching is done by a special component called a commutator. Think of the commutator as a switch that flips the direction of the current every half turn of the loop. This constant flipping of the magnetic field keeps the loop spinning continuously, transforming electrical energy into mechanical energy, and that's how an electric motor works. Section 5. Real-world wonders, electric motors in action. Electric motors are everywhere. They power countless devices we use every day. From the tiny motor that vibrates your phone to the powerful motor that drives an electric car, these marvels of engineering are essential to our modern world. Electric fans use motors to spin blades and keep us cool. Electric drills use motors to rotate drill bits and make holes. Even electric cars rely on powerful motors to turn their wheels and get us from point A to point B. Next time you see a device in action, think about the magic of electric motors at work, silently and efficiently transforming electricity into motion that powers our lives. It's a testament to human ingenuity and the power of scientific understanding.